This video is about the basics of hypothesis testing. Hypothesis testing is what we're going to be doing for basically the rest of the semester. We're going to use what we learned so far about probabilities and distributions and put them together to test whether samples are significantly different from the population or not significantly different from the population. And we're going to be doing problems involving proportions and means in this section. So the rare event rule is review. This was when we were talking about how far a value was away from the mean, like how many standard deviations away, and we could say that it was unusual. So we're bringing that back, as well as using distributions with the mean and standard deviation and calculating test statistics like Z. These are all things that we will be using throughout this next unit. So we are going to define hypotheses in statistics. You may have learned about hypotheses in a science class. We're going to be a little bit more specific in this class in order to be able to test hypotheses using test statistics. In statistics, we write our hypotheses in pairs, and the first hypothesis that we write is going to be the null hypothesis. The null hypothesis is a claimed value for a population parameter. And by parameter, we could be talking about a mean or a proportion. And the symbol for the population mean is mu. The symbol for the population proportion is p. So this is going to be some value that perhaps we're trying to disprove or test to find out if it's an acceptable claim or not. So we begin with the assumption that it's true, and then we're going to reach a conclusion, and we will either reject the null hypothesis or fail to reject the null hypothesis. So there's an example here for a proportion one. This would be the population proportion equals 0.5 or 50%. If we were doing a means problem, let's just say a mean could equal 12 inches perhaps, or 35 miles per gallon. So those are different options. Typically the null hypothesis, you use the equal sign to indicate that the value equals some claimed value. The alternative hypothesis, we use the symbol H1 or HA. I'll typically use the HA for alternative. This is going to be somehow different from the population parameter claim. And the only thing that you change when you're writing the alternative hypothesis is the sign. So in the null hypothesis we use the equal sign, and in the alternative hypothesis we're going to use less than, greater than, or not equal to. So I have examples here for proportions. Here the population proportion is greater than 0.5, not equal to 0.5, or less than 0.5. So after you've written the null hypothesis and you're going to write the alternative hypothesis, the only thing you could change is the sign. So for these mean ones that I gave you, the mean equals 12 inches. Say we were looking for, possibly that the mean is not as big as that, so we'd use mu as less than 12 inches. Okay. So mu stays the same, the symbol, the number 12 stays the same. Same for this next one, the miles per gallon one. Say we think the miles per gallon is going to be bigger than 35, we'd use the greater than, and then the same number. So the number stays the same, the symbol stays the same, the only thing that's changing is the sign. So let's do a few examples. So in these examples, we're given a claim. And remember, that's always going to be our null hypothesis. So the null hypothesis, we have 80%. 80% is a proportion, so we're going to use P, and it says just 80%, so P equals 80% or 0.8. That's all you need to write. In science classes, you may have written full sentences for your hypotheses. You can do that if you want to in statistics, but the only thing you really need is the symbol form, the math form of the hypothesis. So in the alternative hypothesis, since it doesn't say anything about being less than or greater than, we'll just use not equal to 0.8. And that's all you need to do to write hypotheses. This format, so the null hypothesis saying equal to, and the alternative hypothesis saying not equal to, this is the typical format. And you should use that format unless you have a good reason to do something different. Sometimes the problem might tell you to do something different, but typically the null hypothesis always will say equal to. The alternative hypothesis usually is not equal to, but you might see less than or greater than in the alternative hypothesis. You typically don't see a sign other than equals in the null hypothesis, but I'm going to show you a couple examples where the null hypothesis is going to look different. Again, don't use these two examples unless the problem tells you specifically to do so. So if it says that the claim is at least 80%, that means that in the null hypothesis it's 80% or anything bigger, so P would be greater than or equal to 0.8. So again, now we don't have equals in our null hypothesis, and again, that's something that you should rarely do. The alternative hypothesis has to be the opposite. So that would be anything less than 80%, 0.8. And the second one says less than 80%. So in the null hypothesis, P is less than 0.8. The alternative hypothesis has to be the opposite direction, which would be greater than 0.8. And being equal to 0.8 has to fit somewhere. It can't go in the null hypothesis, so we have to put it in the alternative, greater than or equal to 0.8. And again, both of these, don't use this format unless you have a good reason to. So stick to having the equal sign in the null hypothesis and then not equal to, less than, or greater than in the alternative hypothesis.